That's
I was like, oh wait, it
yeah.
just looks like a shipping crate.
Yeah, that's right. Yeah. Okay, so are we good to go here, Mitch?
Yeah.
All right, so let's get started then. Okay.
How did you take it?
So these are the two climate chambers that SMT designed in partnership with UVic. It's basically an R60 wall system using 4 XPS panels and a VIP panel all the way around that's been sealed. And the goal, I think, is just testing materials in different wall systems long-term for research projects. I don't know where to go with that. There's baffles in order to maintain air circulation and increase the temperature stability in the test area. The goal was to reach, or at least get as close as possible to the ASTM standard of guarded climate chamber without at a lower cost point. And the data loggers that are being used with this, there's a 48 channel resistance data logger on each unit that are testing 32 temperature sensors with the ability to test an additional 14 resistance sensors, as well as 8 channel voltage data loggers that have heat flux meters that will be able to be used on the samples. And then with that, those are all going to be connected via a CAN connection to the gateway computer, which is going to be used to test the jobs and run the different experiments, as well as upload the data to the cloud so that it can be exported from anywhere and kind of be analyzed at a rudimentary sense and then transported to a different data platform if more advanced analysis wants to be done. But yeah, the whole goal was to try and make it as versatile and as repairable as possible because we knew it was going to be in a student lab. So each component had to be relatively low cost and modular for different research purposes. So instead of a very specific way of attaching temperature sensors to the inside, we went for a way that could be adjusted as they went, and that was extremely low cost in changing. So there's a lot of zip ties and a lot of adhesives. Yeah, that's kind of everything that was done on the project. From this point, I think we were just going to set it up, try and get it to a point where some readings can be taken and some temperature stabilities can be taken, and then me discussing with Armando and maybe Mitch of the kind of the next steps for the integration of whatever heater and cooler is required, and if there's different set points directly on that and the temperature stability that is brought with that, or if relay control from BIG is going to be required, which is something that the gateway unit can do. So different outputs and control settings can be adjusted directly from the temperature readings that are coming to the gateway. So then we can cycle power if that ends up being more efficient. But from my commissioning tests in the office, the temperature stability, because it's such a small box that's sealed and it's an R60 wall, it's pretty good. So maybe that won't be required. And then that's less on the burden of the operator to kind of deal with. If you can just have a set point on the heater and chiller, and then you can carry out your tests and you're reaching a good temperature stability that's stable with the air circulation that the fans provide. Yeah, that's kind of it. At this point, it's just installing everything.
Sounds good. Okay.
So,
Any questions for Khaled?
yeah, is there any questions?
Let's move on. And,
I have questions, but they'll probably get answered as soon as we start going through it.
Yeah, so there's 2 fans that are going to go into each unit, and then they're going to mirror each other. They're the exact same. So we can do one first, and then it should answer a lot of questions. And after that, we'll just rapidly do the other, or I'll do it. I don't know who's sticking around and who's not. Yeah, each unit, on the back of it, there's marked sections for where the 48 channels can be mounted. Since there's so many sensors that are coming directly off this board, cable management is a bit of a challenge because it's going through a 2-inch conduit because you only want to have to seal as few penetrations as possible in the box. What we did with this is we have a can of spray foam that we thought if it's really important in a test to have as good a seal as possible, you can spray foam it, and then if for some reason you wanted to move all the temperature sensors and change everything, you could rip the temperature sensors out and the spray foam would just come out and it's basically starting from scratch. So It's the only way we can do it. But with that, you have a lot of cables going through one conduit. And it's manageable, but annoying if you don't mount this first and bring them through in some sort of sequence or order.
Yeah.
If you bring the whole bundle through alone, it's a challenge.
Yeah.
Especially since the temperature sensors go to different points in the box. They're all going to be a slightly different length. So you're going to, basically I'm getting at, do it slowly.
Yeah.
Get temperature sensors to where you want them and keep your cables clean.
Lads, well familiar with that. He cut it twice and it was still too short.
Yeah.
Okay. All right.
With that, also the fan controller is mounted here. There's discrete fan control for both of the boxes. There's 3 settings. It's just a regular voltage controlled fan, but they're 2 muffled fans. They're quite powerful. It circulates air quite well. Those attach directly to the baffle. So if the test requires like a larger heat source or just movement, because we wanted to keep the temperature sensors all in the area of the test area, which is in front of the baffle, it's just flexible. There's enough lead on the fans that you can move it quite a bit.
Okay.
What else? For the heat flux sensor, it's on a different data logger. It's an 8-channel DAC that I included just because it's flexible for the future. There's 7 channels that it's not using right now. So if there's any 0 to 5 volt voltage sensors that for some reason you want to use on a different project, this is here. Obviously, if you take it, put it back. But that's not my problem.
Yeah.
So
Alright.
yeah. The way that the 48 channel board and it's documented data sheet, and I'm still putting together a bit of a manual that maybe if you send me this video, I can kind of work off of, because I'm kind of going right off the top here.
Yeah.
But the way that the different connections for the resistive 48 channel board is, it's a Bix punch. So it's really quick to put in 48 sensors. But if you've never used a Bix punch before, it's a little different. It's not like a screw terminal. It's kind of like a telecom way of connection. And to remove sensors, you just kind of vertically rip them up. It's insulation displacement, so it's easy. And yeah, let's see, what else can I think of here? For the actual sample holders, we included 3 different ways to do it. The original plan was just to have kind of like a little dolly that would be built as strong as possible in order to test either a thick wall or a heavy wall. But in manufacturing team had a lot of different ideas that even I was like, we don't need this, they decided to include, which is this frame, which we can remove, because these boxes alone will slot in together. But there's an additional frame that they included in case someone wanted to just test one homogeneous material or just like put something inside it and seal it, and then they don't have to build this in like a stud frame. It's already here. So alongside that, we also just have a ledge, which when we were testing, you would just screw it into the top, and then you'd be able to just rest anything on it, which we found kind of helpful. That's kind of all the components though.
Okay.
For the actual connection to the laptop, we use a CAN protocol for our wired data loggers, and there's a way that you can daisy them all together so you only have one Ethernet cable coming from the computer, but it's also, there's some prerequisite knowledge to do that, and I didn't think it was necessary to push that onto whoever used it if they wanted to do something custom. So we made a patch connect that would take one Ethernet cable coming from the laptop, and then you could put any kind of normal Ethernet cable, not even a CAN proprietary RJ45 crimp, and go from each DAC. So if one failed for some reason or someone stepped on it, you could just buy an Ethernet cable and go from that patch connect. Yeah, that's kind of it.
Okay. So what's the next step? Are we unpacking some instrumentation or?
Yeah, so I guess the next step is probably going to be unpacking instrumentation, mounting the 48 channels on the back of the box, starting to thread them through, deciding if where I put these like cable runners, because I used zip ties and zip tie mounts as adhesive, are appropriate. So I'd run through 3 down, and then they hang to the appropriate heights so that you get a full gradient of the 3D space. But maybe this isn't what's desired in a certain test, but I think it's the best starting point. And then after that, I'm also gonna run the fan controller cables in first, and one of the heat flux sensors. And from when I was doing this, there actually is an order that makes it a lot easier. Do heat flux, fan controllers, and then temperature sensors. Because if you want to run those fan controller cables in after you have 32 cables in that conduit, it's not the easiest thing in the world. You're kind of stuffing. Yeah, that's kind of it. After we do those, I'll probably hook it up to the patch connect and then the CAN transceiver and then the laptop, and then open up the software, do an example commission, and show how the jobs of the test can be arranged. Because in the software, there's the ability to make different jobs of data that will independently be synced to the cloud so that you can organize tests well and name them properly. Yep. So many boxes.
This computer that can be used for setting up everything.
Oh, cool.
Unless.
Actually included the laptop.
Oh, okay. Well, that works too.
I wonder if I should.
Ask it again.
Yeah, yeah.
I'll start with start with the outside frame. Yeah.
Okay, it's recording now.
So the outside frame is removable, so we can do like a sample built into the frame and then,
Exactly.
and then install it.
It's just another way to put a sample between the boxes.
Okay.
Like the boxes do fit together without this frame.
Okay.
There's a lip on both sides and they go together.
Okay.
So-
So when we remove this, it'll still mate to that one.
Exactly.
And then this is built so that it will also mate once there's sort of like a big concrete sample or something.
Yeah. It's just another way to put a sample between
It's
the
an
boxes.
extension.
It's an extension, essentially.
Do you know what sort of weight rating we have for something like this?
Not for this frame.
No.
I know that we built the box so that it could hold a concrete sample,
Yeah.
but this frame is pretty minimal.
Okay.
Yeah.
I guess that's why you have that.
That one has a double stud. It's a double stud little platform so that something can be built on top of it. And then the ends are designed to slide underneath this.
Oh, okay.
And where was I? Yeah. Was there another question?
Well, yes, I guess you're building two different environments, and
Exactly.
then you're putting your sample here.
And then they mate together.
Or you can lock it as a single box and
Yeah.
study a piece of a wall.
And a lot of our testing too, like the goal of this was so that you could test two different climates with a sensor in between and a sample. But a lot of our tests with heat flux sensors will put a heat flux sensor on the hot side, and the other side is just ambient. And a lot of the time that is enough to kind of characterize a homogeneous or like basic material. So even if just one side of the box is used for that, it's still a valuable piece of information. You don't need to necessarily need to bring this to 40 degrees and bring this to like -20 or -40. And in some cases that might introduce more variability to the sensor readings because things operate differently at different temperatures. It's like you can almost get a better rating of a material at like +15 and like 5,
Okay.
like that 10-degree differential. But a lot of that is just in literature of testing materials, and I'm sure Fagoni does it better than I do. But it's just, yeah. But in cases where you do want to test a material with two extremes, that's what these boxes were designed for. So it's kind of like even, I lost my train of thought. Yeah, that's kind of it.
Okay.
Yeah.
Okay.
So are they more, like these boxes, are they more designed for horizontal transfer, or you have setups to vertical?
No, they're almost purely designed for horizontal flow. Like the way that the walls were designed to R60, we're trying to minimize losses through the walls as much as possible. Like, you know, direct flow towards the test sample because the thermal resistance of the walls is so high. Because realistically, there's not going to be a lot of R60 systems that are tested. And in a lot of different like chambers, the variation between the sample or whatever they're testing to the wall system is a lot smaller. They use like an R20 wall. But when we were designing it, we were like, it doesn't seem like this is better. Like, why not have a larger discrepancy between the test sample that you want to test flow through and your chamber that you're trying to use to provide resistance to heat.
Right.
Because the biggest difficulty with testing a material is getting a directional heat flow because you have losses everywhere. And that's kind of the challenge of an in situ heat flux installation, but you try and minimize that in a hot box setting. Yeah, that's kind of it.
Do we have an official name for this device?
No, you can name it what you want. We named it SMT Climate Chamber because it was a one-off custom design. It's not like we're going to be making these all the time. And I really hope I don't need to make them all the time.
Normally it will be called a guarded hot box.
A guarded hot box?
But does it count as a guarded hot box?
It
Yeah.
cannot meet the standard.
It doesn't meet the standard. So if you want to name it,
We can call it a hot box.
Quasi-guarded
Or
hot box.
a climate.
quasi.
You can call it a climate chamber. That's probably simple. At the end of the day, guarded hot box is also a climate chamber.
Yeah.
Just be good to have a unified nomenclature for it.
Oh yeah, that's a good idea. But let's see, what else is there? Is this all just packing
Yeah,
materials?
that's just packing.
So that's the DAX, plug sensor, tap screws, patch neck. So yeah, there's going to be one of these 48 channel boards going to each of the boxes. So just so that you can picture like what 32 temperature sensors going through this is, it's that. And yeah, these are the axial muffin fans that are going to attach to the baffle. And these are purely to circulate the air that is being heated by the cooling, or by the heating element or the cooling element, because that direct zone is going to be hotter than the rest, right? So that's why this baffle that, one here too, this baffle exists. It's purely to improve temperature stability in the test area. And we also used it to attach the fans, so that it's just moved easier. Okay. There should be screws somewhere. So these are the heat flux sensors and the data loggers, and these are the first thing that should be ran through. So there's cable, and then the instrumentation wire that is on the heat flux sensor is pretty delicate. It's calibrated to the heat flux sensor from the manufacturer. So just when in use, try and keep it safe. And this is attached to a 1,000 time gain amplifier. And this is the cable that will actually be ran through the box. So the plan is you get it to this, the signal's amplified so it's stable, and then you run this cable, which is durable, through the box, and this is what you maneuver. And then on the outside of the box, this is the 8-channel voltage jack, which takes all the readings and sends it to the gateway. Yeah, for sure. So there's a data sheet that I'll supply with all the wiring diagrams, but really once this one's done once, this will never really move.
Okay.
The way that the terminal blocks work for these, they're just clamps that are spring loaded.
Okay.
They're not insulation displacement, which is something I've had to tell quite a few people lately, because it seems like they are because they're spring loaded, just through convenience. And this is a pressure fit, which a small screwdriver can release it,
Okay.
but ideally you don't need to. Just pull it out, and then you'll be able to thread it through the device. Yeah.
How much do you want to feed out?
Just feed it all the way out and then I'll stop it. Yeah, that's good. So the plan with this is to make sure you have enough lead so that you can test wherever in your assembly you want to test. So you can make it really short and you can put a sensor directly in the center. But if for some reason you wanted to test the corner, make it longer. But at the same time, with a lot of these test apparatus, the best place to test is the center of the sample. Because although edge effects are minimized, they're not gone, right? So that's that. Then I'll get the fan controller. This is easier. Yes. Okay. And the way the fans work is that this fan controller controls two fans.
Okay.
So the fans will mount to the bottom of the baffle,
Yeah.
and you want to, I'll mount them so it won't really matter.
Yeah.
But you want to face the terminal connections in a way that they're easily accessible for when you actually use the device. So you want to face them out,
Okay.
because when the baffle gets put in and you connect them to the fans, if you just put the fans in any way, it could be a way that you're like almost reaching blind.
Okay. That makes sense.
Yeah.
Sure, one of these things, so we'll screw them up and you realize, okay, that's why it says so.
Perfect. Thank you.
All this looks familiar, doesn't it?
Does it? The reusable zip ties?
Yes.
Oh, you don't have to take those off yet.
Oh, okay.
One thing I wanted to try and do, which I didn't do when I did it the first time, is spread them through with the zip tie and then take it off.
Okay.
Just because I feel like it'll be easy to organize on the other side if you can pull out a bunch.
That makes sense.
Yeah. But that just might be scoping from a poor experience.
We'll mount the board first.
Yep.
Yep.
You want to do it?
I'll need you to hold it.
There's some pre-drill holes. Whatever.
Hey, just like IKEA, eh?
Yeah, just do a half drive.
For IKEA, you get the Allen key with it.
Yeah.
You have the right screw size, isn't it? So
Yeah. And there's the bumpers on this one. Cool.
Careful not to step on those.
I can pour them, I guess.
Yeah.
Oh, yellow was in there already.
I might organize them first. Make it look a little cleaner.
I'll install the.
So right now they're all the same length.
Yeah, right now they're all the same length.
Okay.
I'm gonna install the fan controller, just so that's not gonna get pulled back through. Doesn't matter which way.
There's one way that like I think it's that way.
Sorry, let me to bump your head.
Half drive is on. I thought there was half-inch screws in this, but I didn't see it in the packaging.
Okay.
Is there any reason not to take down those cables? Probably shouldn't yet.
Pardon?
I was just thinking if we could take down the ones that are already there, but no.
Tape down the cables.
Well, just in case you want, like inside the tube, just so they're
Oh yeah,
rattling around. But it's fine.
we could.
In case we don't have to adjust anything, it's
Okay.
probably bad.
this isn't a good idea.
Do this. Yeah, take the
Right? Oh yeah, do that. That's a good idea. So when you do this, it doesn't matter too much, but doing it in a way that makes the cables look nice on the outside, always recommended.
Yeah, cable management is something we try and.
Yeah.
And I guess once you decide the length, you're trying to keep the short ones on the same side, I guess. Would
Yeah.
make sense.
I'm giving you guys, I'm just giving you some additional thermistors.
Oh, okay.
There's some, these are 10 footers, which are good enough to get to any point in the box. But when I was doing it, some of the farther ends, just for like cleanliness and cable management, I would have preferred 15s. So I just gave you 15.
So they're all 15s?
These are all 10s.
Okay.
But I just have 15
Extras in my backpack. Okay. Good to go on all those?
Thanks, man. Okay, that's good.
Oh, sorry.
No worries, no worries. Okay, that's good. One thing is, if you guys end up deciding on a more permanent place in the box that you want the thermistors, you can shorten them. Because there's going to be some that are really close where you can pull it out,
Yeah.
so it looks less nice on the outside.
Okay.
But yeah,
We can always tie them up and loop them back. On
that's
the
what I
outside.
figured. I
Yeah.
just wanted to keep it flexible.
No, that's, yeah, there's nothing quite as annoying as having things that are too short.
Yeah, exactly.
Hold on, I'm gonna move so we get that other
Oh
guy.
yeah, sounds good. I'm forgetting about the camera.
Yeah.
So with the thermistors, there's 32 in each box currently. You can just add more.
Okay.
There's nothing against the design that we kind of followed, which I think was a University of Manitoba low-cost hotbox apparatus. They use 32 per side, but like I've given you 15 more, so just add them.
Okay. And these are standard thermistors that we can get from
Yeah,
anywhere,
you can
right?
buy them. I'll give you the DigiKey part number.
Okay.
And then if you want to make them in-house, make them in-house. They're really cheap. And specifically for that model, we directly do the conversion in big, in
Okay.
the software.
Okay.
So it's really easy. I'm struggling. But I also don't want to cut the cable.
Anybody wants to help him out with the other ones? Taking the tape out?
Does everyone just carry knives?
Yeah.
Yeah, we do.
Over there.
The rule around here is if you don't have a knife in your pocket, you're not really an engineer.
Not.
Well, you need to be able to eat your steak.
Yeah, exactly.
Well, then I'm in trouble. Might just mean stacked in there.
Well, but Mitch's steaks are so tender that that'll be just fine.
Cut them with a spoon, the heel of your spoon.
We're not talking about steaks anymore, so we should record this, yeah, okay?
One thing that I did do is I made a default schema of all the sensors, which of the temperature sensors that are already on the 48 channel board, they're labeled and they're in order and exportable.
Okay.
So if he, it is like a half of what he would need to do.
Yeah.
Like
He would just have to attach
the
like
location.
yeah,
the
a
position.
location. Yeah.
Yeah. So what I did here is I used these zip tie mounts and these zip ties as a track, and then it would be like you bring the temperature sensors through, and then if you want vertically 3 sensors here, you drop them to different heights, and then if you want, you can clean it up. But that's the basic idea. You can put them anywhere. That was the biggest reason why I went this way. And you couldn't really drill into the inside because there's a penetration that condensation could accumulate in, or you just have a penetration on the inside of the box, and that's not what you want in this case. So it had to be adhesive. If there's a point where you want permanent mounts, I just put a pack of Gorilla Glue in the case, just glue it on. But I feel like for a lot of the tests, you'll want to be able to move them.
Yeah.
So yeah, it's a really cheap way to do it.
Well, we're well versed with the adhesive mount, so.
Oh yeah, I love the adhesive mounts.
So does Ariel.
Yeah.
Took the tape off too soon.
Yeah.
So the main reason that I put 15s in is this one. I put this one here because I ran it on the ground because it looked better. Because otherwise it's coming from that corner. It's going around the baffle either through the side or above it. And it's getting to this lower corner of a temperature measurement. And that's why I included all the 15s.
Okay.
Because I was like, this is annoying. I don't like this. I was a little worried about the adhesives coming off. I've done this like 9 times with what we have here, but they haven't come off yet, so they're pretty good. If you do like a firm pull, they come off, so that's good.
He's sitting on the floor for someone to step or trip on.
Oh yeah, rolling.
So if you add sensors, the computer is automatically going to detect it or the reading.
Yeah, so the software will automatically see that there's a new resistance reading. That's going to be the output of the sensor. And then you pick the conversion in the software. Because the data logger is polling at a rate, it will take every reading within 30 seconds. It'll just keep cycling. So you're going to add it and then you can see it. Or like it'll be disconnected and you add it and you put it back in and you automatically see that reading start coming in. And you can label it and make a schema if you want. Because what I did with exporting a default naming convention that you can import, you can do that again as many times as you want. And then you can save those files.
So then do we just basically copy the same setup for one of the other sensors onto the new sensor?
Yeah.
Is it that simple? Like just like copy and paste, or we just click a drop down box and select
Yeah,
it?
so one way that you can do it is you can right click the sensor and you literally just pick MF52 temperature sensor
Yeah.
and it'll be done.
Well, I guess we'll go through the instrumentation after, right?
And then if you want to mass do it, you can select all of them and you can make them all temperature sensors. It's pretty easy. Yeah. It's a little finicky once you don't know what's really going on, but use it for a little while. It's really easy.
Okay. Is there ability to add in a humidity sensor to this?
So these ones, these voltage-based sensors,
Yeah.
you can do that.
Okay.
And then once you add a humidity sensor here, if you want it temperature compensated to a temperature sensor so you have a more accurate reading, you can do that from the temperature sensors from the other DAC in the software.
So it'll do feedback.
Yeah.
Okay.
So
Just because knowing the humidity inside like each side.
No,
could be-
definitely. That's
could be
something
something
you can
that we
do.
could have as a feature down the road.
Yeah.
Okay.
And then one thing that Falguni also discussed that we never really followed through on because we don't have the cooler and heater situation on fully is if the energy wanted to be monitored, like the energy out or that's being consumed by the heater
Okay.
to see, like if it's an electric coil heater, I don't really know what you have.
Yeah.
The efficiency should be near 100%. So you can see how much power is being put into the heater and how much is being outputted.
Yeah.
And I don't know if that's valuable to researchers. It is to
Yeah, it
some.
would be. Yeah. Yeah.
But that's something that all can go to the same gateway.
Okay.
So we can use, it might need a different data logger because it's reading pulses probably, but it's something that can all be collected in the same gateway and be filed in the same system and then exported
Okay.
pretty easily.
That's something we struggled with on the other one was
Yeah.
being able to actually,
Use different sensors.
well, no, being able to measure the actual power consumption
Yeah.
by the system in order to actually determine like an accurate heat flux.
Yeah.
So if that's a functionality that is mostly built in,
Yeah, it's mostly built in. And there's we use Continental Controls watt nodes
okay,
as our pulse monitoring platform most of the time for really, really high accuracy stuff. But we also, for a project a couple years ago, we integrated something called TED, Home Energy Monitoring,
yeah,
which is for just a few inputs, it's still about as accurate as Continental Controls. But you can, there's this item they have called a spider, so you can monitor like 8 discrete systems using one device.
okay,
And when you use that, they say that it's like 8%, like plus or minus 8%, which is quite a bit,
yeah,
like long term. But from just like the base unit itself, it's a lot cheaper than the other units, and you don't need a pulse DAC from us exactly. But you can still import that data straight into analytics.
okay.
So it's like a $400 option for that energy monitoring that's still getting to the same place.
Okay. I might want to have a talk with you about another project separately after.
Yeah, for sure. I'm here today.
Okay. Well, that's the idea.
I want to do something. Oh yeah, so this is the one that goes to the corner that when I tested I didn't like.
Yeah.
I'm just gonna put 315 inputs in and pull them to this corner.
Right now.
Yeah.
Okay.
If that's okay with everyone.
No, that's fine.
Yeah. And then I can show you.
And then we'll do it on this one as well.
Yeah. Like see this one?
Yeah.
Like it barely reaches. It'll
Yeah.
get the first two
Yeah.
pretty well. But when you have that baffle in it that's moving back and forth, you kind of want cable to be as tucked back as possible.
Yeah.
Just for cleanliness, and then if you want to put cable mounts in the back, that's why the 15s are here.
Okay. Yeah, that's fair.
Sounds good. Yeah, I was having a hard time with that one. So,
So should I remove this ring then?
Yeah, for sure. If you could do
It's
that.
just the 2 screws?
I think it's just the 2 screws on top, and it should just come off.
Oh, there's also a bracket on the bottom.
Oh yeah. Yeah. So to add sensors to the 48 channel,
Okay.
I'm adding 3 15-foot temperature sensors so that the far corner can be reached more easily and it can look a lot cleaner.
send, so I probably won't do this. Do that.
You take the 2 leads, they don't need to be stripped because it's insulation displacement. And this is a Bix punch tool. And you will just line it up and punch it down.
So do we have one of those little tools here, or we don't? We need to get one.
This was not included. I
Okay.
actually
Yeah.
didn't have one. I had to
Okay.
ask someone for one.
Oh yeah. Okay. No, I guess it would be good to have the proper tool.
It might be good to have one of these,
Yeah.
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 So yeah, that's kind of the entire process. You could snip them, clean it up, but once this is done, it'll start reading. It should be good. It's already monitoring. If this was on, temperature readings would come in. I'm just gonna thread these through and get to that far corner. Yeah, that should be it.
We should label those. No one has a chance.
Yeah, these should be labeled now.
I think we have a pen somewhere.
Should I do the other one? Because
Yeah.
long enough?
Let's see. Not sure what the last labels were, but I'll just do like 10, 15, 1 or something like that. Sure. This is dead.
It's dead?
Yeah.
It's not a Sharpie. Give it a shot. I have no idea.
Might be easier to write on the
Alright.
fridge.
Oh yeah. I got one.
Okay.
Sure. I'll do that here.
Or I guess we'll do the other end of that guy too.
Pardon?
Do the other end of that
Yeah.
guy too.
Definitely. I made sure to label both sides just for down the road.
Yep.
Yeah, so once you hook it up, you'll be able to test it. It's basically, you'll feel it. There's kind of a little like it kind of pops in, right? When you press it down. Yeah. That's the connection. But obviously you'll test it if you ever add a sensor, and that's kind of it. It's a good way to do a lot of these connections at once. A big spot.
I need a plier side.
We'll get the secondary from Verinder when he comes back. He's got nice flush cuts.
Recording now. Okay.
Okay. I guess I restart.
Yeah, go for it. Yeah, we start from it. Yeah.
Yeah, the sensor was designed as if someone was monitoring a building or like multiple buildings and they were all going to one computer. So in that hierarchy of how the software and the cloud software is laid out is that there's a project, and for this there's going to be like a UVic test chamber project. And then in that, people can create their own jobs. So if you make a new job, all the data that you collect, if it's activated, will go to that job. And then you can upload that data to the cloud if you want, so that you can export everything from there.
So rather than just trying to save individual files to like specific like file format type for a date, you can just create a job
Exactly.
and then it runs everything.
Yeah.
Okay, that makes sense.
And then you can, from the online platform, let's say you want to only look at data from a certain time period, you can export that. And you can also data average to a uniform timescale.
Okay.
So let's say you were getting readings every 30 seconds, but all the data loggers were taking things at a slightly different 30 seconds. You can average in those 30 seconds and you can move your readings so that they're in line. And let's see what else. So here, I've only connected one 8-channel WiDAC and one 48-channel. And with this system, since it's wired, the readings just automatically start coming in. So you can see here that there's 35 sensors reading on this 48 channel. 32 are the ones that came in like when we were here originally, and then we added 3 more.
Okay.
So right now they're just saying new sensor. But one of the things that I did on this job, I'm just gonna delete this. It's gonna try and add its own stuff. But what I did do is I made a schema. I made a schema somewhere. Well, I have it backed up, and I'll put it on this laptop. But it has all the names of every temperature sensor already put into it. So you import that schema when you make a new job, and everything's labeled already. And then if you end up having a certain test procedure and those sensors don't move, like you know this is top left, you know this is top right, and you name things, you can export a schema, and then you always have that. So you don't have to relabel it, which is a big thing, because it takes a lot of time. And So just using this as an example. So the way this works is that data points will come in and they'll be in raw resistance. And then you can either right click, configure, name it, and pick a sensor type. These are just the defaults that we have in our database. And so this is temperature, and it's an MF52. Save, and it will just immediately convert the entire series of data for that sensor to the sensor conversion. And with that, you can also do like a bulk configure, sensor type, and it converts everything to temperatures.
Okay.
So even if you added like a humidity sensor to the voltage data logger, you could still do this. It'll just come in on a different channel and then you convert it to something else.
Yeah.
And if
And I
you-
can say you can also create your own equations right on the spot there.
Yeah, exactly.
So,
If you just have, if you try and integrate some other sensor that we haven't provided, and it's still 0 to 5 volts and it's still reading, you just put in what the quadratic formula is.
Yeah.
Yeah. I wouldn't be surprised if you guys end up using these data loggers for things possibly unrelated to this box.
yeah, why not?
And that's kind of it for the software. After this point, you can sync it to analytics where you can do graphing and more analysis or export or data averaging. And then in analytics, you can do all these equivalent conversions. It takes longer because it does a database like actual SQL change as opposed to here where it's really quick. So even if you forget to do this, like pick a temperature, pick a sensor type, you can do that in post once the data is already in analytics. Yeah, that's kind of it. That's the system.
Okay.
Okay.
Do you have any other questions, anyone?
So is it recording right now?
Yeah.
Okay. And it'll record until you what, turn off the program, or?
If you, turn off the program, you can actually kill power from here and it'll stop recording.
Okay.
But that's only because it'll stop taking USB power and they'll think it's switching to DC. Because really, you can put these sensors on like 1,000-foot CAN network and power it with external power, and the data loggers will work.
Oh, really?
But we're using this in like a 10-foot area. So it's
Okay.
not really required. Yeah.
So then, if it's not hooked up to the computer, it's just
It's just dead.
dumping the data.
If it's not hooked up to the computer?
Yeah. Like if it's being powered, that data isn't being stored anywhere, right?
Yeah, it's not doing anything. Because the data from there is directly being sent to the laptop. There's no data logging
Okay.
in that DAC. Maybe data logger's not that
It's like a
appropriate.
lab view.
Yeah.
Yeah. We do have wireless data loggers that do have logging, but that wasn't. We don't have a 48 channel fix.
No, yeah.
Yeah. Because power becomes a large concern when you're doing long term.
Yeah. Well, that's what we have over on that thing right there is the built-in data logger.
Oh yeah, what are you using?
I don't know. It was spec by one of the grad students.
Okay.
I can open the box and show you after.
Sure. But to everyone who is going to be using this, does that kind of make sense? Like I'm going to include. I have manuals. I have videos for commissioning and syncing. I have videos for graphing data. That's all stuff I can provide.
Yeah.
Okay. Yeah.
So
Yeah,
the
because-
sensors can measure multiple, like the temperature or humidity or whatever stuff, depending on how.
These
What you want from
sensors
me?
only monitor temperature.
So what did you change right now? Like, you confirm-
I changed from raw resistance
Okay, to temperature.
to temperature.
So now, in terms of reading frequency and
Oh yeah.
that sort of thing.
So the way with these units, we call them WIDACs, and they're part of our wired monitoring family. You can either configure the polling rate of each unit directly, or the way that we really do it is we control it through this. So you go to devices, double click there, and then you can get the timer. Oh yeah, you do get ID to see what's connected to the unit. So here, the different node IDs will be spit out. and then you can get the timer of a specific node. And then you can change it. So right now it's sampling at a 120 second frequency.
Okay.
The lowest you can really bring it is about 30 seconds, purely because it takes like a tenth of a second for each measurement, and there's 48.
Right.
So you can't really push it faster than that. Yeah. But this probably actually isn't helpful. But if you're only doing voltage readings, which that unit is, you can get to sub-second readings. But this is not really... I guess it's like an advanced thing where if you really need it, I'll show you how to do it. But it's not really
That might
the
be another
typical
need kind
usage.
of thing,
Yeah.
Yeah, don't see really any need for that. anyways.
No, we'll probably deal with that another time.
Yeah. Yeah, does that kind of sum it up?
So once you've done some testing, how do you want to look up the data? How do you do that?
Yeah, so you'll go to, you can either set it up so it's syncing every 5 minutes or something.
Yeah.
Let's say you want it to run over the weekend, but you want to look at the data from home.
Mm-hmm.
You can set up a periodic sync. It would just be in settings. You can make it set every so and so minutes. It's saying this because it's uncommissioned currently. Because I'll commission it to a project, which would be the UVic climate chamber testing project, and then jobs will be made in that.
Okay.
Can you set us up with a full run through of basically an initial setup from start to finish, including doing the job,
Yeah.
run it, and then output it, the analytics, like we can sync it to the cloud or wherever, or we can just sync it locally, and then get the data out so we can see that whole process
Yeah.
from start to finish.
I can try that.
Yeah.
Okay. I can do that right now.
This is why I wanted the keyboard.
Let me just go. Let's go to analytics too. It looks nicer. So we have a.
So I just typed analytics to
There is,
research.ca.
My bad.
Just
I did the wrong
translated what
thing.
he's doing with his
I
fingers.
typed the wrong
Okay.
thing out.
Alright.
Analytics2.smtresearch.ca.
There's a correction.
Okay.
Oh wait, I need to connect to the internet.
Yeah.
I'm on the
This using your
spot.
mouse tab. Yeah, just click
Which one
here.
do I connect to? This one? Should I just go here?
Yeah, you will have to.
No.
Oh, tech team.
Touch
Try
team?
that. Do you remember what's the password for that? Oh, maybe is that the one that maybe next door? Because we have the other one that we have set
I can
up
just
in
hotspot
Finland.
to my phone for now for the demo.
Oh no,
Yeah.
just go to. Who are you going to be using this first?
Yeah.
So why don't you just log in through your
Yeah.
UVic account?
Yeah, that might be a good idea. I mean, you should really create a profile.
A tech profile.
Well, his own, but
Yeah.
whatever.
Well, we can drop it right
I may need to cover up the keyboard as I log into my admin analytics account.
Oh, I'm not recording the keyboard.
Oh, really?
No.
I thought you were.
No, it's not. Well, it kind of looks like at the beginning because you're showing the full frame. When you're
Yeah, yeah.
recording video, is 1080 is cropping it up and the bottom.
Oh, okay.
Actually, 1080, 4K, anyways. Yeah. Well, I got moved a bit, so now it's showing a little bit of a keyboard. But okay.
There's video guides on how to do this if you ever actually need to. Your list will only have one project in it, so don't worry about that.
So basically what will happen is that each tester will make for their specific test a job.
Okay.
So let's say, I don't know what the date is,
It's
7/23/2019 commission test. Sure, that's the name. You create the job and then you activate it. So now any data that comes in,
What do you do for activating it?
there's a button that says
Oh, okay,
activate
sorry,
right here.
sorry, okay.
So you just highlight it and you activate it. And then at this point, readings will start coming in to the specific unit. So
That's outside. I totally thought that was in the
outside.
box.
I thought that was here.
So those fans aren't quiet.
It's more than 110 here.
Exactly.
The fans working.
No, they're probably not turned on.
They're not turned on. They're not turned
They're
on.
not.
So all the data will come here, and the bucket that it's being put into is the activated job.
Okay.
So from this point, because it's commissioned, and it's also recording data into this job, you can sync it. It goes through the process. You can see in the bottom left corner that's syncing. There's going to be a bar, and then we'll go to analytics.
Okay.
So you can go to analytics at that point, and after it's like a minute or two as it goes into the database and files itself, you can see all the data that you just collected.
So this analytics, is it in the computer or is it up on the cloud?
It's online. It's in the
It's
cloud.
online.
Yeah.
So is it on your server?
Yeah,
somewhere?
exactly.
I think this is the same software program that Sarah is using.
It
on
is the same software. that
Yeah, I
Sarah's
thought
using.
so. It looked a lot like.
Because I was like, this looks, as soon as it started cycling, I was like,
This is familiar.
this is Sarah software.
Yeah.
Yeah. We.
No, I heard
So
you
you-
were both helping her.
So are you? Is your company that's been working on that sensor then?
Yeah.
Or- oh,
I
okay.
designed it. That was me.
Wow. Not that Falguni ever made a connection for me that the two things were related to the same company. So, anyways, okay. Because when I said it, I seen
It
that
seems
before.
familiar.
Yeah.
But yeah, I was like, just get Sarah to use the 48 channel board. She's used it enough.
Yeah.
Okay.
Because that's the same board that's on the back of
Yeah. Okay.
this chamber.
Yeah.
The source of so much frustration for me.
Yeah.
Yeah, but that was a fun discussion.
Yeah, you were both
Yeah.
working on the seal, right?
Yeah.
Yeah, the seal was a lot of my life for
Yeah,
like 3
but-
months.
But you see now what that looks like, right? So,
It looks really nice now.
Yeah.
But she told me that it was an adhesive membrane that ruined the seal again, or something like that,
Oh.
or made it seal less well.
Maybe. I don't
If
know.
there was a problem now, she not reported to me. I don't
Yeah.
know if she.
I think she finished
Yeah.
the answer project. And
Yeah.
she
Okay.
was
Yeah.
good.
Is that the one that's outside? Which project are you talking about?
The water column.
Oh, okay.
So now that job that I created, it exists here, and then every job that is created in that project will be able to be accessed in this dropdown. The one thing I'm not sure is if you want researchers to be able to access other people's data, and there might be ways to protect that or just create different jobs if some of it's more important.
Generally, I think
it might be okay.
Yeah.
I don't think we're going to have concurrent researchers on this at the same time. I think it's going to go in different sections because what you're probably going to be doing is going to be totally different from Alad's.
Yeah.
And they're probably not running at the same time, right?
That
Yeah,
would be
so
rough.
Cannot be.
yeah, because I think there'd just be two logistics issues with that. Would probably be too difficult. So it'll be one person at a time,
Yeah,
and
that's
then
fine.
they'll probably also have their own logins,
Exactly.
so that
So
chances
even
are
if
it'll
it
be
is
separate.
one person at a time too, I can make a new project,
Yeah.
and then they can file all their jobs from different tests in that project.
Yeah,
That's not a
Yeah,
problem.
that's better. That's better.
Yeah,
like have it be like Malat's
Different,
project,
yeah.
Steve's
Exactly.
project,
and then they can learn how to commission to their project.
Okay.
I have a video for that, so I
Yeah,
don't mind
okay.
people learning that. But that's kind of the entire process, and then you can view it in several different ways. There's just the summary. I don't know if data's going to be here yet. There's a oh yeah, it's here. The summary of all the data that's been transferred. You can browse to specific sensors and graph it that way, because sometimes just if you think of it from the expense of the database pull, just looking at one sensor will be faster than looking at all of them. This doesn't really matter for most people, but I've used this enough, and like those seconds matter to me. You can make groups of sensors if you just want to look at several.
So if you want to look at the lowest level of the
Exactly. And you can set alarms
Okay.
so that you can get triggers in case something's gone out of bounds in a way that you don't want it to.
Like if all of a sudden you start getting like stratification
Exactly.
between each
Yeah.
layer,
Yeah.
you know the fans probably
Yeah.
stop working.
Talking of which, I don't know if Sarah ever made a recommendation that we made that for their project
Yeah.
with the column of water. If so, it doesn't need the assistance of somebody. The moment that you have a leak through the membrane, it automatically opens a valve and drains the column.
Oh, we could have done that. She didn't tell me that.
We
So
told her-
what I have, where is it? Sorry, I don't want to.
No, that's okay. Yeah. I can stop this for now.
So
There is no keyboard in anything else.
let's do.
No, I've actually been looking for padlock keys, and all of the padlock keys are not around the inner key drawers.
That's concerning.
There's been some padlock keys until recently.
It just means they're just.
I have there. That's also possible if they're still there. 'Cause
This is stuff that no one will have to do. I'm just setting up the admin side of this
No.
project.
I gotta get going in about an hour.
I think we're pretty close to where I was hoping we'd be at the end of this.
Okay. Realistically, it's more important these three know it than I know it.
Yeah, I guess so, eh?
Yeah.
Yeah, 3 of us will remember. Right.
So basically, there's going to be a project called
just-
UVic Climate Chamber Testing, and then this is something that'll happen very rarely or not ever, but it's commissioning the computer to that job. I'll use my account for now. I moved it.
You want this one too?